This is the first time I'm going to be trying to stream on TikTok. I don't know if it'll work. And I'm using Restream, so it shows up all funny. I think it's going to just show up as like... I think it's going to show up as like horizontal, and that'll be kind of weird. Is it streaming? I don't know how this works. It says streaming. But when I go to the app, it says nothing. What's going on? And hello, everyone. Well, no. Oh, there's a download live studio. So TikTok has a live studio. This is a whole new world. Go live in both portrait and landscape. I wonder how this works. Oh, it's probably like for actual streaming. This probably is not for me. I just wanted to use OBS. Good morning, Poisnada. How are you today? I went to Paris Game Week yesterday and I saw some retro stuff. The new stuff wasn't as interesting. Switch 2, like, whatever. I'm not super into it. This thing's still installing. So today I wanted to just kind of go over Nix the language again. Do a quick sort of recap of Nix. I haven't played with it in so long. So we'll do that, some of that after I get set up here. Probably need a bigger font so people can see. I'll switch in a moment. Why do I not see Restream chat? What a pain in the ass today. I'm just like not getting anything working. Haha, great. But what are you doing, Poznada? What are you up to today? What is your plan today? Don't know how to pull this chat out. Alright, here's Restream chat, so I should be able to see this also. Alright, so we're going to do Nix today a little bit, and then I might have to work. I might want to do other stuff. I might play around with the Commodore 64. I don't know. It's all over the place. Maybe it's Haskell today. But let us see what happens with Nix first. That part I just want to review real quick. Yeah, there's like no way for me to see TikToks live. This is so lame. Installation complete. Let me see what happens if I try to launch this thing. I think it's just a toy. I don't think like TikTok's really a great platform for someone like me. Create a collaborative text editor in Elixir. That is so cool. Um, are you gonna use like CRDTs? Let's see here, TikTok. Maximum number of attempts when I tried to log in through TikTok. How lame, right? Yeah, so this thing's more about going live with it, but that's not what I want. Well, I don't know. Maybe I can like do it both at the same time, separate applications. But whatever. All right. So let us try and look at Nix today. I'm going to need a browser page of some sort. So let me open a browser. Let me point it at Nix. And then I'll share my screen. All right, we're almost there, guys. All right, this is not the browser I really want to share. I think this is it. And we want to share our shell, but it's hidden. All right. I think we want to move our shell over here, and we'll make this smaller by just a bit. I don't know. How wide should this be? What did I used to do? Didn't I have some kind of setup here? Maybe this used to be a little bit shorter. Right? Something like this. Whoa, this is really small now. All right. I think that's good enough. Usually we have chat here somewhere. Where's that? Ah, here. We will just refresh this. Something like this, right? Oh God. I don't know. I'm a mess today, guys. But we're gonna still do what we need to do. We can figure this out. Hey B, how are you doing? I'm using an approach that updates using deltas and diffs, trying to keep Postgres from crying, but it's going to be expensive anyway. I wonder how's that gonna work? So two people, I've heard about people doing like cheap CRDTs using diffs. The thing about CRDTs, or I guess, collaborating, is like people making conflicting changes, or like I type something like hello and then you delete my E, but then I delete my whole word hello and I type in, world. So like your change where you changed like one letter in hello, it doesn't know where to go. Especially if your change was delayed somehow, right? Huh. Sounds a little complicated, but good luck. I kind of want to create like a simple CRDT sort of thing. All right, so let me do a little bit of Nix here. We're just going to go over the language like as fast as possible, I think. Let's see if that like even works, this idea of like going as fast as possible. Hmm. All right. So I was like noticing that on I was noticing that on my YouTube pages that like, I have a ton of languages that we've gone over. We've learned Erlang, we've learned some 6502 assembly, we learned some Rust, some Haskell, but like the stuff that people have watched the most is Nix. I don't know why. I think it's like just something that people are interested in. But it's complicated. It's like sounds really cool, but it's like shit, it's really hard to use. So it's been a while. Like I use Nix every day. This machine that I have is Nix, right? It's Nix OS under Windows subsystem for Linux, but I also have a laptop for work that's just Nix OS, just plain Nix. And I know it's like kind of a pain to use if you don't know what's going on. You kind of feel like monkey do, monkey see sort of thing. Monkey see, monkey do, because you're just like copying commands and you're like just hoping it's going to work, right? At least that's what I hear from a lot of people who watch my videos. So we're going to just start off like the previous time we did it in my Nix series. Like I was learning it too, so I didn't know it much. I have a thing where I prefer learning over actually like um I prefer learning over actually doing, like reviewing and teaching. So I've been hesitant to go over stuff that I've already learned, but today we're going to go over yeah. Nix is important as a technology, but the documentation is terrible. So I really appreciate your videos to help me understand what I'm doing. All right. Yeah, thank you. So let's see here. Let's see. I wonder how fast we can get through this. All right, guys. I'm gonna see if I can actually like record this too, because maybe I can turn this to a video. All right, so we're gonna go over Nix the language and see if I can help you understand it. At the same time, I'm gonna review my stuff. Usually in my videos, I actually read everything because I'm learning it the first time. But let's try to just get through this quickly. So you need to install Nix. You can just go to the website. It's not hard to install Nix. And remember, Nix is both an operating system, packaging manager, and a way of life. Just kidding. Well, half kidding, half joking. So here we're talking about Nix The packaging manager, it's actually also a language. The packaging manager uses a language. So when Nix is annoying because like it's an OS, it's a packaging manager, and it's a language. So when you say Nix, it kind of means different things to different people, right? But we're going to be learning the language, and we're going to be doing that probably through Nix Shell, which it comes with which comes with the packaging manager. If you have Nix OS, great, but you're not required to have Nix OS. You can just install Nix the packaging manager, and you'd be able to follow along here. So they think that it will take an hour if you're familiar, and 30 minutes if you're proficient. Probably going to take us longer because we're going to go probably play around with examples. So it looks like I've forgotten about this, but there's a REPL. And we can just do stuff. 1 plus 2. Nice. And how do you exit? Control D exits. And then here is an object. So like in TypeScript, you have objects sort of things. This is an object. It looks like JSON, right? So we can have an object. This is the key, and property key, and this is the value. And now we have a equals 1. And then you can do something like a is equal to another object, b is equal to 2. I have to remember. This closes this. This closes that. So now we have a is equal to, I forgot the thing that makes it spit everything out. Or Elixir maps, yes. But here what they're showing you, instead of like nesting it like this, you can just do a dot b is equal to 2, and it'll do the thing for you. So there you go. Oh, fully evaluate does not match. Try prepending $p to the input expression. How the hell do I do that? This? Okay, so we just do this. There it goes. Now it prints the whole thing, right? And then you see my old one where I did this. It's the same thing. So these two are equivalent. Okay, so now we have a Nix file, and the way we can, let's make a Nix file. Thanks, B. I forgot so much. I'm so ashamed. File.nix. Shit. And in here, we're just going to do 1 plus 2. So we have an expression, right? See that? So we're not going to type it in the REPL. Instead, we want to run it. So this is going to instantiate the expression. And there we go. We have 3. And I assume we can edit the same thing. Whoops, that's not what I wanted. And we can turn this to a dot a, what the hell? A dot b is equal to 1. And then we call Nix instantiate. And there we go. There's probably, what is it, minus print here? Ugh, help me out. I've forgotten. But anyway, it's the same thing. We just have to find the flag for it. It uses lazy evaluation. If you want to not use lazy evaluation, use minus minus strict. Oops. So here we go. Strict. There we go. Look at that. Thanks, B. So now it prints out the evaluation, the full thing. White spaces are used to delimit lexical tokens. Otherwise, they're insignificant, so it doesn't really matter. So we also learned about a let expression here. If you're familiar with functional programming, then this probably isn't too surprising. So we'll make something like x is equal to 1 in, and then what do we have before? It was like a dot b is equal to x. There we go. So you see that? See what I did there? Now we were able to set the variable, and now when we run it, it prints out 9 instead over there. So let is basically doing all the setup here. You can do multiple lines here. Whatever, right? We're not using it here. But yeah. So there we go. We have another object where we use two variables. Names and values. Values in the Nix language can be primitive data. Oh, I'm not supposed to read. What is this saying now? I don't know what it's saying. So I don't know how people just like speed run these things, because what do they do? It's like, what are they saying here? You're gonna miss something. Attribute sets. So the name here is an attribute set. This is basically a map, right? And you can see here, this is an attribute set. It's probably a pretty bad example. It kind of makes you think that these are types, but these are just like attribute names, just like A, B, and C. Um, I guess they think people know JSON, so these are similar things here. Which means that if we go back to our example here, um, you know, we can have like greeting equals hello world, right? Um, and we can also have outro is equal to 3. And here we have a string. You see here we have a string, but obviously outro number is equal to 3. This is a different data type. So you can see that they have the string things there. So we have booleans here, we have strings. It looks like we have nulls. Let's move on. Attribute names usually don't need quotes. List elements are separated by white spaces. Right. So this is an interesting thing. I think Haskell does the same thing, doesn't it? It's been a while since I've used Haskell. But I think we can just make my list here and make it equal to 1, 2, 3. And there you see my list is elements 1, 2, and 3. I think it'll interpolate numbers here. Yeah, is 1, 2, 9. It put X here instead. Oh, right, recursive sets. So, usually if you have something in here that inside of your attribute set that refers to another item, that doesn't work. But if you want to make it work, you have to put in recursive in here so it knows to evaluate it based on the dependency chain. I think I've gotten bit by that. But you take a performance hit, so don't do it just because you want to do it all the time. We already did let in. We already showed it. Nothing surprising here, right? You guys get that, right? You give it two numbers, and then we can just add them. So you need semicolons to separate here, and then the last one is just an expression. So you don't need anything there. Ah, okay. So where's the in let in? What's it trying to say here? Maybe I'll just ignore this. Only expressions within. So here we have a let. This is the let. X is equal to 1 in X. I see what they're saying. So they're basically saying that because we have a let here, right? That this X here is only available within this in. So you can't use it outside. That would be kind of like outside the scope of it. Attribute sets with a dot. We already looked at that. C is equal to name is equal to Elise. What I do wrong? Oh, it's just not used. So we're going to return two things here and C. Whoops. Too many languages. Okay, so it's just saying that we can access this by typing C dot name to get to an attribute. So my name is equal to Elise here. That's what that's saying. With expression allows access to attributes without repeatedly referencing their attribute set. So if you don't want to type a dot x, a dot y, a dot z all the time, um, some attribute set is equal to, we have this. Okay, so now we have this thing called some attribute set, right? And it has A, B, and C. And then let's say I want A and B. I can, in here, say with some attribute set, and then you put a semicolon. So now it's going to prepend some attribute set. So I should be able to do first A. Fuck. Second B. Right? First 10, second 5. And you can see 10, 5 here. So this got basically replaced, so I didn't have to type some attribute set dot first, which I guess should still work, right? Yeah. No. Oh, whoops. That's not what I meant. That's not, I said the wrong thing. So I don't have to type some attribute set dot a here. That's what I meant. And yeah, that works. It's the same thing. I just don't need to type this. It's like an alias in Elixir. They used a list here. I used the attribute set. Doesn't matter. All right, let's keep going. We got through this. Only yeah, some kind of scope thing. I'm sure it's obvious. Inherit. I always got confused between inherit and with. So let's see. Inherit, inherent and inherit are not the same words. Inherit is shorthand for assigning the value of a name from an existing scope to the same name in a nested scope. You see, this is why, like, this documentation just makes it a little complicated because if you really read it and you pay attention, it makes sense. All right, but we can look at it here. I see, yeah. So it's just basically taking the pair, key value pair. So remember when I had to like fake and make like new keys here? Um, Instead, I could just inherit this stuff. I wonder if I can string these two things along. No, no, no. You don't want a string. They're doing two different things. So if you want to just, if I want to just bring down, no, I do. So with this, and then I want to inherit A and B. Oh, that goes inside. So what I'm thinking is that this with makes it so I don't have to type some attribute set dot A. You see what I mean? And inherit's going to make it so A equals 10 shows up. Look at that. We figured it out, guys. We figured it out. Did that make sense to you? Do you want me to explain it real quick again? So this one with the with just basically means I don't have to type this. And then in here, I'm returning an attribute set. And with the inherit, I'm just grabbing some attribute set dot A and some attribute set dot B and just bringing it down here. And that's why I get A equals 10, B equals 5 when I ran it. Hopefully that made sense. So inherit basically brings down the pair, the key value pair, and with basically means an alias. You don't have to type it. And you can limit what you inherit. Oh, this seems like shorthand for basically what I just did, right? So we did it with a with, but looks like I can basically do this and get the same thing. So this is shorthand for the with. String interpolation is always good to know. So we want to interpolate a string. Name equals Elise, and let's put in A in here. Do you guys think this will work? Undefined variable A. Uh-oh, isn't this how it works? Probably we just can't do it. Yeah, we can't do that. So let's put a new thing in here called name is equal to foobar And then we're going to use, well, is it like this? Uh, cannot coerce integer to a string. Oh, it only works with strings. I'm sure we'll learn how to do that in a minute. Foobar Elise. So I grabbed my name from up here and printed it over here. Notice that I had to type in some attribute set. So if we use with and we use some attribute set, isn't this how it worked? God damn it. With a. Expect binding. Inherit. Oh. No? Unused with. Ah, here. There we go. So the width comes where you're trying to access it. So it didn't belong here. It belonged on the right side. And then this part is going to have the width enabled. And so C, it's going to turn it into some attribute set dot C dot name. And then so we get foobar Elise, right? It's going to go up to C here and get my name. And then when we run it, we get name equals foobar Elise, right? Oh, did I not type it here? No. Aha. New bar. Let's see. So this will turn into foobar Elise new bar, right? There we go. Perfect. Thanks, B. Did I type it over here? Did I do this? God damn it. Okay, we did inherit string interpolation. Only character strings can be in string interpolation, so how do we do it without... Oh, they don't really explain it. You can concatenate with plus. So we added a whole bunch of ones at the end with the plus concatenator operator. Right, sometimes we'll see, but no braces. So if we see this, this is not a concatenation. All right, indented strings, multi-line strings with two. Okay, so let's just clean this up. Intro text. Here is my biography. I didn't do well in school and missed a lot of classes. Still, somehow, I got a job. And now let's just try to print it out. Well, it did it. It put in like new lines here, but it's not formatted when it prints it out. That's okay. File systems, file paths start with slash, so we can like give it slash stuff. So here's shell.nix. Is that how it works? My file equals home nixos projects nix. You see it turned it into an absolute path there. Built-ins to string, perfect. All right, so this turns the A into a string, so we'll get our intro text with the number 3 added to the very end. So 3, there's our 3. We learned about the paths already. Angle bracket syntax. So this is where we can look up paths. It tries to find this thing in your path, I guess. So that means I should be able to just do my packages is equal to nix packages. And then here we're just going to print it out and we'll see where our nix packages is. It's in nix store this thing. That's where our packages are. And I'm guessing it's an actual like directory. There we are. Yeah, so it has all this stuff in it. All right, now we're going to learn about functions. Functions. Let's make a function. Add to. And it takes in. Oh, this is just yeah. It takes in a single parameter and then returns it plus 2. Then how do we call it? You just do it like that. So it returned 12 because we made a function add 2 here. It takes in one parameter and there's the function body here. And if we want to do like add and it takes, if maybe such a thing already exists. We're going to put in one add 2 here. Is this, why does it not happy there? Previously defined. Oh, just because I my syntax was wrong. Okay, and then my add is equal to my add 10, 20. These are just keys. Like maybe it's confusing. Key 1, key 2. Right? So here's going to call my first function, my second function over here. And we have key 1 is 12 and key 2 is 30. So that's how we do those functions. Did we skip anything? So yeah, what was the syntax? You got a colon, and then you have your body. This is a little bit like lambda calculus. You're basically passing in these two parameters, but really they're just functions. This is like a function that takes a single parameter that takes in a function that takes a single parameter and then it binds it. So they're always really taking one parameter, but you know, you can think of it as a function that takes two parameters. And yeah, like probably often you could probably like we didn't really play around with lists much, huh? No, let's not. I won't bother. So we can also take in parameters that is an object, that is an attribute set, and have a default. Not too complicated here. Let's see if we can make one that takes in a list. And it takes in, I'm not really sure how to even say this. Well, we'll do it once we get to a list. We'll just make an object for now. So my function is equal to, and then here we have how it's defined. We put in the keys, A and B. Those are the keys within that object, and the function can actually return something, right? It can do add to. We might have to make this recursive. And now we pass it in an object that has A1, B is equal to 2. So we got 5. Oh, because I did add 2. I should have just called add. My bad. My add. So this should be 3. Oops. Yeah, my add. Why doesn't my add work? My add takes in ax plus y. Why doesn't this work? I don't think you can supply a list as input to a function because you need the names. Yeah, I was wondering if they had pattern matching for that, but I'm guessing not. Oh, because I'm stupid. There we go. I had a I had a plus here, and then this would add them and pass the single parameter, but it needs 2 parameters. There we go. Yeah. I see you said it. I have a little bit of a delay on my side. We did calling functions. We can return functions. We can have curried functions. That's what we were talking about earlier. X, Y, X plus Y is really a function X that takes in a function that takes in a Y and adds the two. So it basically looks like this. Um, and you can see in here that this thing is a function too. So it basically curries, which means you should be able to do something like my add 10, right? So here, just saying it's unused, yeah. That's okay for now. Well, we'll get rid of this. So here it's going to return a function because myAdd actually takes two parameters, right? So it's going to return this function that is a function that takes in a y. So if I run this now, I get a lambda. But now I can do value 2, which takes value 1, which is a function, and I'll pass another function like 100, another value like 100. Undefined name. I thought I could do this. Oh, I got rid of it, that's why. There we go. And then when I run this, I get value equals 110. So this is a partial function. It's not fully instantiated. And this one we fully instantiated because now it can actually return the value, the body. There's nothing more that for it to actually continue with. So to be clear, this is a function. That's what that is. Why did it get rid of my crap? There it is. Curry function. Attribute set argument. This looks like pattern matching maybe. Let's see. Yeah, I think we already did this. That's exactly what this is here. We need a function that takes in specific, it needs to take in a parameter that has a and b. So if I call my function here and I pass it in like 10, oh my god, please stop with the different languages. Ah. I can't. I can't. There we go. Value equals 30 because we added these two numbers together, right? But if I pass in an extra thing in here, I think it's going to be unhappy. Yeah, it's unhappy because I think you need something in here like this to tell it can take extra parameters. There we go. Otherwise, it's going to have to match exactly. Now we can give it default values. So any one of these can take in a default value, like let's say B is 10. So now I can like skip passing B, and it should basically add 10 and 10 and return 20. So my value 3 should equal 20. Yep, and it is 20. I don't know how to like, I can't, oh, I have a restream page here. 1 second, I just want to ban this block list. All right. So we did the default values. You can have multiple default values. Additional attributes, we just learned that. Named attribute set argument, at pattern, at syntax. An attribute set can be given name as, what is this saying? Oh, this is just the rest of the args here. I see. So if you want to get the rest, you write it as args. Here, think it's just args, right? And then what we'll do is we'll add them, and we'll add them. Does this make any sense? You see it's 50 here, val3 is 50, and that is because we did myAdd A and B. A and B is just 10 because B default, oh no, B defaults here to 10, so it's 10, 10 is 20. So it's 20, and then we add 20 to C. C is 30, so it should return 50. Was it 50? Yes, it was 50. Hope that made sense. I guess there's no type checking, so C, like, I could just, if you don't pass a C, it probably breaks. Let's not pass a C. Yeah, it's like, attribute C is missing. Function library, so we have a bunch of built-ins. ToString, we already learned that one. Import is really important. Import basically brings in functions, right? Most built-in built-ins, a notable exception is import. So it means you can just call import. It takes a path to a NIX file, reads it, evaluates the contained NIX expression, and returns the resulting value. That's why we often do, let's say like NIX packages path is equal to NIX packages, right? So here's this is going to look up the path like we figured out earlier. And I guess we can just do like val4 is equal to import NIX package path. I don't know what this is going to do. There we go. Val4 is lambda. So it's a function. Whatever NIX packages returns, it returns a function. But that's basically what it does. Packages lib. All right. I need to take a break to. I'm so close to the end. I was kind of wanting to speed run through it. How much time have we taken? Where is the stream time? We're at 1 hour exactly. So 30 minutes. I guess we're not advanced. Or we just like to play around with stuff a lot more, right? I think I'm going to make tea. So let me see. No, there's no way for me to. Oh, yeah, I can pause the recording. Pausing recording. But what? I think it's paused recording. But you guys are still watching me stream. I can't pause the stream. So today was the first time I tried TikTok, and like streaming on TikTok, no, like no, zero engagement. I'm not even sure it's working. Or how would I even know if it's working? Seems weird. Oh, maybe I'm streaming on a different account. Could that be? All right, I'm going to make tea and I will be right back. Okay, be right back. I forgot my cup. Can't make tea without a cup. am waiting for it to brew. Here, we'll take a break from this. I wanted to kind of figure out why I can't see my TikTok stream. I think I'm logged in as the right person. Yeah, it's me. Oh, it says I'm live here, but not on my app. Weird, huh? It says Nazir's here. Hello, hello. Oh well. No idea why I can't see it otherwise. How are you guys doing? How is everyone? Waiting for my timer to go off so I can get my tea. We're going to finish this language tutorial. It's been a lot more fun than I expected. Okay, it's going off. I'll be right back. Gotta be right back. Gotta put in my message. There. B, what did you say? You're doing well. You're all doing well. Happy that I've actually understood what you taught me in the other videos. You did. You remember more than me. Congratulations. Doing well. Okay. All right, we're gonna continue now. I think it's working. All right, so where are we? So we have the Nix library functions there, and then we have the built-ins, and then we have the library functions. So Nix packages has an attribute set called lib. And we have all the functions in lib, and we get it through packages.lib, as it's usually called packages by convention. So if we import this, I see. Let's look at our code again. So we've imported this, right? So this is returning a function. So when we import this, this is evaluating all of this. And now if we really break this out, we basically can take val4, which is basically this function, and we call it with the empty attribute set. So this is actually calling the function now, and we're not passing any variables. Let's see what this gets us. A whole bunch of Stack Overflows. It's probably too big because Nix packages is probably huge, right? Anyway, val5 you would call like kind of packages, right? It's kind of the packages. So now I can do kind of packages dot string dot, oh wait, why is it not working? This is import. This should work, no? What's it saying? Oh, right. kind of packages dot lib dot strings dot to upper. I'm going to pass it in a string, all lower. No, I don't want to print this though. Shit. We should put this up on the let so we don't print this. Otherwise, it's going to try to evaluate it and it's going to be too much. So we're just going to do this. We import it here. So we get the packages path, and then we call it like packages imported, right? And now we're going to do packages imported. We're going to actually call it. So we're going to call packages invoked. What happened here? Unused binding. Why is this the... Oh, because it's recursive. Shouldn't this work? Maybe I need to make this a recursive thing. Okay, so I just made a recursive attribute set so I can kind of like call the previous versions, right? Next packages invoked, and I'll just call this like P to make it really short. Looks like add2 is unused. I guess we got rid of it. And then here, we're going to call P. You see that? Oh. Oh, now we actually have access to it. So upper should be an uppercase version of this. Ah, fuck! Attribute lib missing. Why? Packages lib. Isn't this the exact same thing? Import packages. Packages invoked. Ah, here. No, that's why. Because I need to call p.packages invoked. There we go. So all up, the upper one is now all lower, but in capitals, you see? My mistake was I forgot to call, like we have an attribute set here, but I needed to call packages invoked in order to get the attribute set lib on it. That is equivalent to this whole thing here. I just wanted to break it up so you guys see that there's nothing magical here, that this is just a path. There's nothing special about this other than it's in your path and it found it, right? And then here, we're importing it, so it's going to evaluate it. And then we need to actually call the function that is returned by it with something. I think there's a whole bunch of overrides you can give it. That's how Nix basically configures stuff. But this is how it all works. So that's where we are. Impurities. So far we only covered pure expressions. There is only one impurity in the Nix language, reading files from the file system as build inputs. Whenever a system file path is in the string interpolation, the contents of the file are copied. Okay, so that's pretty cool. I remember that. Um, so what we can do here is we get the path to my file is equal to file.nix. So you can see here that I'm referring to my file, right? And now I'm going to interpolate my file over here, my file. And this is going to grab the contents of my file, turn it into a string, and then call toUpper on it. So uppers should include my file now itself. Ah, shit. Oh, it's only going to print out contains the store path. Okay, so it only prints out the store path, Nix store. It doesn't print out the contents of the file, just where it is in the Nix store. Okay, that's fine. We're done with the language. That's it. Like, these are just built-ins now and other things to use. But if you've gone this far, you basically know the language. Um, I think I think I'll stop here because it's a nice thing. Like, if you get this far, you can say you know the language. You can look at just about any Nix file and say, like, syntactically, I know what I'm doing. I know I know what this is. This is an attribute set. This is a list, whatever, right? And the rest of it is just learning the built-in functions and learning the library. What's it called? Packages library? Packages lib. So, yeah, it's a good refresher for me too, right? Like, if you didn't want to like follow my videos slowly, this is just a faster version. I'm not sure what like it feels like to someone learning Nix. Do you think it was way too fast? I kind of just switched back and forth a lot. I'm not sure. But people will maybe leave comments. We'll see. I don't think it hurts to do this every so often, for myself and for people learning, because maybe they'll stumble along a better one for them, a better version of this video. But yeah, I have newfound interest to like use Nix to actually make my own derivations and compile stuff. I use it a lot for my work and my life, but I didn't go very far with it. So I want to go a little bit further. So I'm going to stop the video part now, but we will continue streaming and doing other stuff. I don't know what to do next. Here's my life. I might as well write down my life right now. I'm flying to Berlin tomorrow for Codebeam EU, and that's where I will do a talk on, I think on Wednesday or Thursday, on how to get to use Elixir at work. Or really, it's going to be techniques and strategies to get to use the technology you want at work. What I found that works for me. It's a pretty soft. It's a pretty soft. Well, I live in France, so it's not a far thing. Berlin. I go to like 3 times a year. It feels like minimum because there's so much tech and meetings going on there. I was just there for a local first conference. Work paid for that, but this one I'm speaking at, so they don't pay for everything, but I have to pay for the hotel, but it's like a negotiated rate, so it's better. I made like a little thing in live view for it. Um I'm going to use my slides with live view. This is all fake content, but I wanted to test like how live view can do this. Um So I was like, okay, I think I'll do my slides with live view and use this kind of retro look. I like it. I'm happy. And I have a second slide here that's like, this is the talk slowly, softly, surely, bringing Elixir to work. Oh, and then, oh shit, you can't see this well. Here, let me see if I can. There it is. That's what it'll look like on the slides. So it's kind of cute, right? Um, and then I kind of like made Elixir data structure to have like columns and like font sizes and speeds that change. So that's why like here it's very slow and backs up and then like changes font size and then changes the speed again here. Cute, right? I'm such a nerd. Anyway, I have to make my slides. I played around with this tech, but I haven't built the slides. So that's something on my list. I'm waiting for that ADHD urgency to hit that's just going to make me do it. But it, I fly tomorrow and I have 0 slides. I've thought about it a little bit, but I haven't made the slides. So I feel kind of fucked, but I'm also worried that I'm not worried. Does that make any sense? I'm worried that I'm not worried. Like, what a mind fuck that is. And I went to Paris Game Week and saw Vectrix.com, these guys there. Um, their Kickstarter starts in 15 minutes or so. And it's time to do it. No, I like internally inspect and I'm like, do I have the motivation to do it? And the answer is no. It's still no. Still no. But at some point, it's going to change. There's going to be a flip of a switch, and I'll want to. I just don't know when. Usually it kicks in now, you know? But I think before my talks have been a lot more technical, and I felt like, oh shit, I gotta like make it work technically. But this is just talking, so you know me, like I can talk and talk and talk. So I feel like in the back of my mind, I'm thinking like, I can go in with 0 slides and talk. Who cares? But we'll see. Anyway, so I'm gonna buy one of these, and I'm thinking about like learning how to program one of these. I think it's a Motorola 6809 processor. Um, it only has 1K of RAM, so it makes me wonder like $37 compared to 9 for a Zilog Z80. Yeah, here's Vectrex. And I got to play with one. I'm not a retro gamer at all. Like most people who go to these retro whatever things, they're into like retro gaming. I don't like retro gaming, but I like retro computing. So that's what I'm more interested in. Kind of funny how like limited 1K is though, like, you know? What is the HC11E? Why is this quant so bad at like Motorola HC11E. It came from the 6800. 1984. Yeah, it looks like it's kind of similar. It has two accumulators and two registers for X and Y, which I think the 6809 has also. I heard it's actually easier to program than the 6502. So it's interesting. But you know, the Commodore 64 is coming out very soon, the remake of it. I ordered one. Um, so when it comes out, what I'm wondering is like, maybe I should make content for this because it sounds kind of fun. I put down somewhere what would be good for learning Commodore 64. Do you know how to program the Commodore 64? Jim Butterfield. I heard this was the book to read. Why can't Firefox open a PDF? Can't it open a PDF? I thought it could. I heard this is like an amazing book, but maybe it's dated, I'm not sure. It is, let's see. So we would learn stuff that just like getting started, setup stuff here. That's 22 pages. Then this looks like kind of a run through of like what would be tantamount to a REPL. Like, hey, how can I print stuff and run stuff? And then we learn more deeper, like what the flags are doing, the logical op. So we learn some opcodes here. We do numbers. Now we get into the addressing stuff. Basic, I don't know. Yeah. So we don't, this is more about, it looks like this is much more about the 6502 and not at all about like the SID chip or whatever. I forget the other names of the chips, like how to do graphics. So that makes sense. It makes the book shorter. I think that's good. That is so cool. A Risk 5 processor. So, I don't, yeah, so like, what are the existing Risk 5 processors? Like, what would you do to them? Are you trying to make a Risk 5 compatible processor? Is that what you're saying? I never really thought about it. I guess like there's probably lots of implementations of Risk 5 because Risk 5 is just a specification, right? Risk 5 Sherry. No. I'm really not a hardware person. Is this it? University of Cambridge Sherry. Architectural protection model. Oh, that's really cool. That sounds a lot more useful than learning Commodore 64 assembly, right? I really struggle some days. Like, here, let me give you an idea of what I have on, like things I want to play with and learn. Um, I already have Nix, which we've been playing with, Haskell, Rust. I learned and used Rust, but most of my Rust is rusty now. I was thinking of doing a series where we just kind of like read from KNR C and just relearn C, kind of like we did with the Nix today, but kind of speed run that. Uh, yeah, understand the architecture, but there's a lot of architectures out there, and I've learned assembly language before, and I've forgotten it, and I'll just forget it again unless it becomes part of my daily life. So yeah, C would be kind of cool because I just remember the KNR book just being like fabulous. It's just such a good book. It made me think like this is how I wish all programming books were, other than like the Little Lisper Schemer, that series. I love that. Um, but yeah, like so few really good programming books. I was thinking of like learning Zig, um, WASM sometime, just like directly WASM would be kind of cool. Have a lot of little things like I want to learn new shell, maybe like Prolog and Z Machine sometime. So many things. Really, the Microsoft Quick C manual? Like, how does it compare to KNR? Is it the same thing? Let's kind of go slow here and just see what happens. Like these little like these images. It looks like a little land plot in some game you play. Some civilization type building game. Binary, data bus. Oh, that's my warning that it's almost time to buy the Kickstarter. I have 5 minutes. I better go get my credit card. No, I think my credit card's here already. Yeah, I'm kind of like, there was a period of time when I got really into like everything digital, but now I'm getting into like I want books again, physical, because I'm just tired of all this DRM stuff. And I feel like now that like I was thinking of environmental issues with books, but I think environment is still obviously very important, but like our soul as like a species of like being able to read stuff and feel ownership of stuff, I think that's just as important or more important for me right now. So I'm kind of leaning on this sort of like I'm buying my music DRM free, trying to find the music that I've already bought and downloading them so I don't have if I have to rip stuff, great, whatever, but I really don't want to. So I've been buying stuff from Bleep, um what's it called? Bloomcat or something like that. They're all well, Bleep I think is all DRM free and Bloomcat some are. Anyway, so let's see. The address bus, you get to put an address in there, and that way you can access a piece of memory. And the data bus is the actual data you're putting in there, not the address, but like usually the thing you want to store. So you might have an address bus that says put this thing here, and either it'll reference the accumulator or something, and you're using the address bus and data bus to make that happen. I moved so frequently I lost access to all my books, so it was quite a loss not having them online. Yeah, right? I feel you. I do move a lot too compared to most people, and it is hard. But I want my core books that I love. I want to keep them more. I'm actually, well, yeah, I'm moving some stuff at the end of next month. All right. So what is this saying here? Um, once the processor sends an address over the address bus and it has been recognized by the memory chip, data may flow between memory and the 6502. So there's 8 bits and it flows over them. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8. It is correct. So whatever those 8 bits are, it could be like stuff we're getting from the memory chip or stuff we're putting inside the memory chip. So that's how that works. Number ranges. 8 bits give you up to 255 unsigned numbers. Um, what is this saying here? Oh, but I think the address bus has 16. Is that right? Yeah, it has dots here. So I'm guessing, I think the address bus has 16. Yeah, 16 bits. Um, so that gives you 65,000 um, different memory locations. The data bus only has 8. So if we want to store a number that's bigger than 255, we have to use 2 different memory um, spots, addresses, and just kind of like do them in 2 operations. Hexadecimal are grouped by 4, so each 4 gives you 50, up to 15. You can count that. Here's 1, 2, 4, 8. And then 8 plus 4 plus 2 plus 1 is 15. Oh, it's time to buy my thing. I'm going to do it on another window though, so sorry. Where is it? I didn't store it somewhere. Vectrex. If you're one of the first 50, you get a deal. So let's see if I can get a deal. Back this project. I'm clicking on it. Ah, first 50 here. It's only 99. I think this is it. What are the other ones? Mini, white edition, all in pack. Oh, you get the t-shirt. I don't think I need the t-shirt. So I'm just gonna go for the early bird. Not early bird. Founders edition. Shipping. Thinks I'm in a different place. I'm not in Belgium. I clicked pay and it's just spinning. It didn't let me. I failed. It failed. It says 5 of 50 available. Continue to payment. Try again later. I missed it. These fuckers. I'm so mad. Well, it just means I'm gonna pay 29 euros more. Bastards. Can you believe people are this fast? It says 2 of 50 available, but like... Oh, I'm so sad. Yeah. Sorry. I'm like just wasting your time. I'll show you what it looks like. 2 of 50 available. Pledge. Continue to payment. Failed. What is this? All of this stuff. Why do they make it so hard? They already made $47,000. Oh my god, they're gonna do so well. I don't think this is real, so I'm just gonna go with the early bird one now. I give up. Well, if I'm gonna go with the early bird, might as well get the. Maybe I should get the. Let's see. The white edition is what? 5-inch, 12 games. White edition badge. No, I think I could go with just a regular mini. Did I back the early bird? Wait, what? ADHD is so tough because 129. Oh, I can't even get the 129. I can't even get the early bird. Do you think this is a Chrome problem? I mean, maybe I need to use Chrome. No, I don't think they even have the early bird one. So I guess I just have to get the regular mini. I feel so sad. No, I don't want to get it. This is the problem when you have expectations and you have expectations, it's bad, right? No, I tried Chrome, but it's the same problem. I don't think it has anything to do with it. They're at 87,000. So 499 backers definitely oh shit. Definitely not. Definitely I don't have the first 50. So, I will just buy the regular mini. I'm so sad. I'm going to email this guy. I met him yesterday. So the good news is when I met him, he was like, "Oh, you're a programmer. We might need some Vectrex games." So I was like, "Cool." So he wanted to keep in touch. So that was cool. What happened to my terminal? There it is. RAM, ROM, interface adapter. I don't know what those are. All right, this is the kind of stuff that is hard to remember, but there's a program counter. This is a memory address that sort of tells you where the next, that tells the CPU the next instruction it's going to run. Then you have registers, the accumulator, where you're doing a lot of the work. It's kind of like MapReduce, right? Where you have an accumulator and you're just doing stuff all the time with it. So accumulator is super used. X and Y usually holds indices so that you can sort of like mm, do a loop across memory, like index of an array or something like that. Status register has, I think, a bunch of flags in it. Um, Maybe that's where the carry stuff is. I can't remember. And then the stack pointer. Okay, so these are the memory, these are the registers that we have that we can use. Um, Notice that PC is twice the width as the other registers because it's 16-bit. I'm still down from not getting the early bird even. I should have just started with the early bird. It's nice to hear a story where you can make something retro and like make so much, stuff. How much are they at now? They're probably at 100%. They're at 100%. Crazy. Damn. Who wants to make a retro console with me? Pretty awesome, right? What else do I have to do today? I have to write my slides. I have to work a little bit. I have to pack my suitcase. And I have choir tonight. I have to leave a little early because I got to do some last minute stuff. I got to pick up an Amazon package. I think I have to go to the pharmacy. Oh, yeah, I have to set up my laptop. I want to dual boot into Windows on my laptop. Right now it's just NixOS. I bought an extra NVMe drive, but I have to install it. I got this torque wrench that I needed. It's a framework computer. It's a beast of a machine, right? Look how big it is. I thought like, hey, it'd be really nice to have a huge machine, but I traveled with it twice. It's just really heavy and really big. It makes me think, no, I might prefer this like small Mac. Just charging it because tomorrow it should be fully charged so I can actually travel with it. I know, I always like last minute stuff all the time. It's terrible. Instruction execution, data registers, AXY, both load and store are copying actions. If load A, LDA, load accumulator, load A from address 2345, I make a copy of the contents, blah, 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 blah. First program project. Do we get to do a project already? We may load one value into A, say the contents of 0380, and load the other value into X. Then we could store A and X back the other way around. That seems like not much, right? We could have chosen a different pair of registers for our plan, of course, A and Y or X and Y, but let's stay with the original plan. We can code our plan in a more formal way. Load accumulator with memory address. When you have the $, you're dealing with an address. 0380, load X 0381, store A. Oh, we're swapping them. I see. I didn't read that. Store A 0381, store X 0380. You will notice that we have coded load A as LDA and load X as LDX. Yep, those are the op mnemonic commands for those machine language operations. We must tell the computer to stop when it has finished the 4 instructions. In fact, we can't stop the computer, but if we use the command break, the computer will go to machine language monitor and wait for further instructions. We'll talk about MLM, machine language monitor, in a few moments. My girlfriend has been away for like 2 weeks in Japan, and it's hard for me. We're super super close. It's such a good relationship. I'm so happy. And but like I miss her so much. She's flying in from Japan now, and I'm flying in the morning, so she's literally getting to the airport like as I'm leaving. How sad is that? So then I'll be gone in Germany for the week. I come back for a few days and then I fly to the United States for like almost like 3 weeks. I'm gone all of November and then I fly back just in time to sing at a choir concert. B, are you in the US? It's kind of, what is it, early if it's in the US, right? Yeah. Well, no, it's like East Coast is kind of late morning. I know, I really don't cherish the idea of going to the US right now. Australian, country of Georgia, right? Nice. Okay, so here we have our first instruction, and this instruction goes into this memory address. I don't know if they talked about that, did they? Guess not. I don't know. Is this the? This is not the machine code for it, is it? No. Oh, I see. This is the. This turns into AD. Let's see. Is this D? This is 1, 4, 8, 12, 13. So it's 13. And 13 sounds about right. That would be 1, 2, 4, 8. 8, 9, 10, 11, 12, 13. Oh, that turns into a D. That makes sense. And then this one is 8 plus 2. It's a 10. So that's an A. So this is load accumulator. And these are just swapped because of whatever network versus little endian, big endian sort of stuff. Who knows? Okay. So address is low byte first. It's unusual, but it's faster by going backwards. You'll get used to it. So they just like put the low 4 bits first and then the next one. And here are the actual machine language opcodes for some common load accumulator store, load x store x, load y store x, break. We can now complete the translation of our program. Load accumulator from this address, and this is load x. This must be store accumulator, right? 8D. Yeah. And this is store x, and then we break. Oh, it's added here. I'm not stupid, but sometimes I am slow. You know what I mean? Does that make any sense? Choosing a location. You always have to, that's the annoying thing about assembly language programs. We usually end up having to like figure out where to put things and finding out safe like places for to write stuff. And if you have an assembler already running, that's taking up memory, so you have to be careful where that is. You might be wondering what's going on in my head. Absolutely nothing. Nothing at all. Just sort of taking a pause. I wish I made money like this. Wouldn't it be cool? Like, if you just had, like, I'm just making money. Yay. Right? That's what we need. The guy from Vectrex responded, "That's amazing. Thanks so much." Ah. Okay. Um, from the for the moment, we'll place it into the cassette buffer. Well, we're not using a cassette, so why not, right? Starting at 033C. That's a good place to put short test programs, which is what we will be writing for a while. This is probably like a different place that we could write it into. How do we get the program in there? We need to use a monitor. Yes. When we are using basic, we use a basic monitor. I never used the word monitor like for anything. I guess this is kind of like an old term. I wonder if we still use monitors. It's kind of like somewhere between a shell and like an operating system or BIOS. I don't even know. PET CBM computers have a simple MLM. The Plus 4 has a very powerful one, and the VIC 20 and 64 have none. Of course, we're going to be using the one that has none, right? After an MLM has been added to it, the sys8 will usually get you there. Three C. That was, yeah, that's what they said there. Yeah, we're using 33C. Where'd it go? Micromon that does this. Okay, try to remember we're not using Micromon. Wait, do they expect me to have a monitor now? Fuck. All right, let's figure out. We got to figure out two things. We got to get the emulator. I think I have one. What's it called? Did I put it down somewhere? We have watchdog kernel interrupts. Yeah, monitor I don't hear anymore. Where is it? I know I wrote it down somewhere. Oh, no. Oh, Altira. I feel like I'm missing something. What is this book called? We're on page 31. It's called Butterfield. Did I write it down somewhere? No. La 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 la. I don't get it. I found this like book somewhere. Maybe it's under C64. No. Ah, here it is. I found it. Commodore 64 assembly. What monitor? Supermon. That's not the one they said not to get, right? Looks like page 31. Micromon. Okay, so Supermon is fine. Let's first get, oh, in Vice? Do I want Vice or do I want which emulator? Let's see. Altera. Is that for Atari? That's probably Atari. Yeah, that's Atari. So is it Vice? Nope. I ran something with Commodore. I just don't know what it was called. Let's do a quick search. C64 emulator. It says it's Vice or C64 forever. That vibe lived in cartridges? What do you mean? Maybe I just ran Vice. Maybe Vice is on NixOS. Emulators. What happened? It should have a Vice, right? Name Vice. So why why don't I have Vice if I just got it? Hmm. Symbolic debuggers. Interesting. So what do I actually, what's the executable I get here? where's their Git repository? Oh, this is in SourceForge. So, but where's the code? I don't understand SourceForge sometimes. God damn it. Oh, well, no, it says GitHub here. They just have a subversion mirror. Here's their code. Oh, but they have like no documentation here. Ah. God damn it. I guess I could just install it in my thing, but I swear I like... What was the other ones called? I thought I ran it through, but it's just weird that there's no Vice even though I installed Vice. And no tab completion of anything else. Hmm. I guess I should just try to install Vice. Normally. Let's see, if I install it outside of Nix, is that a problem? I don't think so. Download it. Looks like I already downloaded it once. Oh, that's what it is. It's just a folder. That's what it is. It doesn't install it. And then how do I run this? Under bin. Under bin, we have C64. Let's see what it says here. Let's see, you download it. Where does it say what to do? They don't say what to do. So it'll just be we'll just try one of these and I'll see if I can bring it up. have a C64 now. That is a device. Did I put it in here? There we go. It doesn't really quite take up the space that I want. Not sure how to do this. Maybe this goes to the left and the browser goes to the right. Maybe that works a little better. Not the best, but maybe we will make do. God, that's ugly. Here, we'll just kind of at least even it out a little. Oh, it's X64. Can I just go to bed now? I thought Nyx was easier. I'm failing at like I'm failing at the basic stuff, you know? 10. Why? I can't print. I can't print my. I have a French keyboard. I cannot make it work. Maybe my numlock. Nope. Pause frame, mouse grabs, joystick settings. Probably under settings. Input devices. Keyboard. Keyboard mapping. US. French. Close. Let's see if this works. Is that a 1? Yeah, that's a 1. Print hello world. 20. Go to 10. Run. All right, guys. Oh, shit. How do you stop it? There. Escape. We're programmers. We're programmers now. So this is hard to read because it's so small. All right, so now we have to figure out how to get an emulator. God, I'm running out of steam. This is like draining the life out of me. What did it say? Supermon. Here is where Supermon is. By Jim Butterfield, the guy who wrote the book, so pretty cool. What do we have to do here? Guys, like, this is not the easiest stuff to use, right? D64 image, is that what I need? I think I wrote some notes here somewhere else. Download the Supermon. Yeah, I think we need the .d64, this one. So we download this. Oh, how do I download it? Is Is there a way to download this? I guess that. All right, so we have that now. In Vice, attach it as a disk. All right, you guys cannot see me manipulating Vice, but there is a file attached disk image, drive 8, and now I'm going to select the thing I just downloaded, Supermon 64 D64. Attach. I'm going to click attach load. Okay. Now it should be in the disk drive. It's basically we've put the floppy in, and now we do load star, comma 8, comma 1, press return. It loaded, and now we type sys8, just like the book said. I feel underwhelmed. It says ready, but it did clear the screen, so maybe it's working now, right? So where are we? Sys8 will get you there. The moment you'll see a display looking something like this. No shit. Fuck, I don't think our thing worked. No, that's not good. Hey, wait, didn't I type run already? Oh, no, I didn't need to type run. But what just happened? I thought I was supposed to type sys8. Fuck. I feel like I'm somewhere now, though. List doesn't work. X should exit. Oh, it did exit. So I typed run by accident and it was sort of the right thing. Oh, sys8 works now. All right, let's reboot. How do we reboot? Reset. Okay, so we're going to try this again. Is the drive attached? Well, I guess we can try loading and see if anything happens. Sys8. Didn't work, you see? Now I type it again. Like, I'm not getting it. Oh, look, this has a peak. It looks like it made this version comes with a basic program that kind of figures out these numbers by looking in the memory locations. So when I did run, accidentally, I did the right thing. So, wow. Well, oh. Memory, so we can see what's in memory 100 to 1010. There's the values. All right. Each memory has, oh, I see. This is memory location 0, and then the next one's 8. So we should see 8 values. 1, 2, 3, 4, 5, 6, 7, 8. And each one is a byte, 8 bits. So remember, each hexadecimal is 4 bits, so it's 2 hexadecimal numbers put together gives us 1 byte. That makes perfect sense then. We have made sense of it. R will print out the registers, program counter, accumulator, X, Y, stack pointer, status register, right? G, it will go to 033C and run. We shouldn't type that because we haven't entered our program yet. Aha, now we're going to type our program in. Should we try to type this in ourselves? Oh my God, how exciting. Instead of copying it, let's figure this shit out. This is where it gets exciting, guys. Here. I think let's actually write it in let's write it in our editor first, so in case we lose it, we can copy it. So what do we have to do? I just have to hide my browser for a sec. No, then I can't see anything. Move my browser for a sec over here. Hide Commodore for a second. And move my terminal back where only you know. So, I don't know what it's called, ASM. So what we want to do is load accumulator with whatever, what was the address we want? Oh, here it is. Load accumulator with, we won't look at the other stuff. 0380. Okay, that should be enough, right? We don't have to look at the rest. And then we load X with 0381. And then we store the accumulator with 0381. And then we store X with 0380, right? So now we need to translate this into machine language. So LDA is, we learned that somewhere else. There it is. 10101101, right? So this is LDA. Oh, wait, we don't want to look at the answer. So this one, what was it? I remember it was D now. So this is 8 plus 4 is 12, 13. 13, you start with 10 is A, 11 is B, 12 is C, and then 13 is D. So that turns into a D. And here, this one is 4 plus 2, which is 1, 2, 4, 8. No, it's 8 plus 2, which is 10, and that's an A. So this becomes an AD. So load is this. And then we need to know what the others are. They don't tell us. Let's turn our memory locations. Our memory locations are going to have to be changed like backwards, right? So 0380, that would look like this, right? 8003. Yeah, 8003. I see. Well, we're going to have to copy this because I don't know the numbers otherwise. So this is AE, this is 8D for store, and this is 8E, right? Okay, now we can hide this again. So we're going to put our address in here, which was like, what was the starting address? Here, starting address, $033C. I'm guessing that that doesn't need to be inverted. Oh, it does. It does. It's a memory location. It has to be inverted. So, did they say that we're going to have to put it in binary there? It looks like we're going to have to... Oh, what? Why are we putting in 1000? That's not... I'm confused. Anyway, so each one is going to look like... This is binary? No, it's hex. Okay, so it's going to be hex. So it's going to be AE 0381 followed by 8D 0381 followed by 8E. Wait, this doesn't look right. Load accumulator is AD 0380, and then here we do 0380, and then we would break, right? And this is 1, 1, 2, 3 bytes. 4, 5, 6, 7, 8. Doesn't that look like that's how that would go? Oh wait, why is this all fucked up? What am I not understanding here? I don't get it. Put it here. 1, 2, 3, 4, 5, 6, 7, 8. Why are we putting these values in here? The 2-digit numbers to the right represent the contents of the memory. Yeah, like these, right? 1000 contains 1, 1. 1001 contains 3A. But there's nowhere where we use 3A11. This is what we wrote. Oh, AD803D. because we didn't swap it. Yeah, I'm stupid. I didn't swap these. That's the program, right? AD803D AE8130. Oh, 03. Yeah, it's 03. I'm messing up. I'm really messing up. Eight zero zero three AE 8103 AD8103 8E800300. So we want to put it somewhere, and that's when we take like a little step thing about monitors. We learn here. You might get display. Oh, so this is just an example display. I'm just reading wrong. Yeah, okay, stupid. I have a real problem reading. I'm so bad. So we can just go up and edit the memory locations. I see. We can actually edit all the registers too. That's really cool. Debugging was kind of simpler in some ways, right? So now we have to put the addresses in here. Starting address 033C. Oh, when we write it in here, we don't write it backwards. So we're gonna put in 033C, and then we have to count C, D, E, so this would be F, right? Yeah, that's F. F 0, 1, 2, right? So this is 2, and this is 42, 43, 44, 45. And then this would be, whoops, 45, 46, 47, 48. Oh, I need 3s for all of these. Right? That looks right. Okay, so we're gonna try to edit it now. We're going to print out those memory locations. It was 033C. Oh, I should put an end. 033C to 03038. Okay, so they're all zeros now. 4, 5, 6, 7, 8. Right, okay. So now I should be able to just edit these, right? Let's see. 3C, AD, oops, oh shit. AD 8003 03. That's F44. Fuck. AE 8103 8D 81. That work? Memory 033C 0348. AD 8003 AE. Oh wait. Yeah, that's right. AE 8103 8E. Wait. Oh shit. I can't keep track. Here, I'll use my mouse over here. AD 8003 AE 8103 8D, and now this will be 81. Okay, and then the next line is we have 81, so the rest is 03. This is so fucking hard. 8E 8003 00. Does that look right? 8D 8103. We missed all of this. 8D81 8D8103 followed by 8E. I keep typing. And it kind of screws it up. 8E 80. Oh no, I have to just use the other mouse button. 8003. Yeah, there we go. Oh, why is it not storing this memory right here? Why is this not working? 038E. Hello? Please store this number. 8E. Oh, that time it worked. What changed? That's so weird, right? 8003. Now it worked. Okay, so now it worked. I really have no idea why it didn't work before. Yeah, does ours look like this? Yeah, it does. Oh, you can't see my browser. Let's put on the browser. Okay, so it looked like this. We got there. We want to swap the contents. We better put something into those locations. Yes, we need to put something into, where is it? 0380. These guys. So we do memory 0380. And we will put in, they said 1, 1, and 9, 9. memory 0380 to 0382. There we go. So it has 1199. And now we run our program. How exciting. G033C. Now we can look at memory location 0380 to 0381. And you see before it was 1199. And now it's 9911. We wrote our program. We wrote our program, guys. How exciting. How fun. I should do like a new video of this, just like making it less like I don't know what the fuck I'm doing. All right. We've been on for about 3 hours, so I think we should stop and I'll just work offline. Or not work. I think I have to get ready for choir now. God. All right. Thanks for hanging out with me. That was a lot of fun. I really enjoyed it. Well, we are a long way from programming anything, but I got to think about like if I make a homebrew game for the C64, what would it be? I'm kind of thinking like a NetHack looking thing. Maybe using like FujiNet so it can connect to an Elixir server and get the data so that doesn't have to use like all its memory for that kind of stuff. But it's still doing most of the work, display, input, game logic, but just like the map and stuff could maybe make it multiplayer eventually. That would be so fun. Anyway, thanks for hanging out with me. We'll do this more. We'll do some more Nix. We'll do some more Commodore 64. Yeah, you don't need the teaching. You're teaching me. I'm like, I didn't know. Let's go check out the Vice thing, by the way, because this was not Vice in Nix. Let's see if the X64 will run from within Nix here. Yes, there's an X64. Cannot open display. 0. That's weird, right? Yeah, I don't know why I can't run. I have X windows. Let's see, X eyes. Oh, something's weird. Maybe you can't run it from within a Nix shell. Let me... Thanks, you're right. I gotta get going. Thanks so much for hanging out. It was really fun. It made my stream feel I stayed concentrated. I need a faster computer. My laptop's faster. I might just switch my laptop to my main computer. It's just that, like, the laptop makes a lot of noise when the fan comes on. Oh, that's so weird. I swear it used to work. Maybe I'm thinking of a different machine. Anyway, that explains it. We are done for today. Thanks so much and see you soon. I'll probably turn the Nick stuff into a video, so if you see a video, it's a repeat content because we're just taking a clip from the stream. All right, bye bye. Have a good day. Sign up for YouTube subscription, whatever.